right, so this is a lesson about probability, and we'll see if we can also try and fit in some fundamental counting principle a little bit later on. Obviously, your probability question counts for a bit more than the fundamental counting principle question does, although it's obviously part of the same section at the end of paper 1. So this is a very typical question on Venn diagrams, so I thought that I would do this with you tonight. So it starts off by telling us that there is a group of 50 grade 12 learners, and that they've answered a questionnaire on which sport they play. So the results of the partially completed Venn diagram below, where R, H, and S represent rugby, hockey, and soccer respectively. So the total number that play each sport is indicated in brackets. Okay, so in other words, 20 people play hockey, 25 people play rugby, and there are 28 people that play soccer. So the first thing that this question wants us to do, let me just scroll down a little bit here, is they want us to work out the values of A, B, and C. So how are we going to do that? How are we going to work out what A is, for example? What would we do? Anyone got any ideas? How do we work out what A is? Okay, so Kahola. Okay, so you're saying 20, that's it. Okay, so we'd start with a total 20. We would subtract 5, we would subtract 2, and we would subtract 10, and that would leave us with A. So that means that A is going to be equal to, that's right, Kamisile, that's what I would have done. What's A equal to? Three, I agree. Okay, so A would be equal to 3. Good job. Okay, so now when we want to work out the value of B, what would we do? Same idea. All right, so here we would need to start with 25. We would need to take away A. We would need to take away 10. And we would need to take away 7. Okay, so what do we get as our answer for B? What are you guys getting as an answer? Me too, Mr. Bavuma. I'm also getting 5. Okay, and then the last thing that we need to do is we need to work out the value of C. How are we going to work out what C is equal to? Any ideas how we're going to work out what C is? So C is this value outside. So in other words, so it's down here. Let me just highlight it for you. So C is here. It's in our sample space, but it's not inside any of the events. So C represents the number of people that took part in the survey that don't play rugby or hockey or soccer. How would we work out how many people that is? So they don't play rugby, they don't play hockey, and they don't play soccer. Okay, so Mr. Bavuma, you're saying 50 minus. Okay, if you do that, what do you end up with as an answer for C, Mr. Bavuma? Did you work out an answer? What did you get? There we go, Kanisile, that's it. So we're going to add everything together and we're going to subtract it from 50. So in other words, you've got our total of 50, and then we can subtract from that the sum of everything. So 5 and A and B and 2 and 10 and 7 and 9. Okay, so in other words, the union of our sets. Okay, so we're going to add the union of our sets, and we're going to take that away from 50. So that means that C is equal to 50 minus 41. And I don't know about you guys, but I get that C is equal to 9. There are 9 people that do not play either rugby or hockey or soccer. Okay, does that make sense? Is everybody cool with that? Let's just check in with you. Are you happy? Making sense? Yes? You got minus 50, okay. Yeah, no, well, that definitely can't be right, hey? Yeah, okay. So this is what you were supposed to do over here, Mr. Bavuma. All right, so in the bracket, this is the union of your sets. So the union of hockey, rugby, and soccer, and you would subtract that from 50, and that would give you the people that play none of those sports. All right. Okay, cool. All right. Well, that seems to be fine. Let's go and have a look at what the next question is here. All right. So if a learner is chosen at random, let's just move this up here, and then what I'm going to do is just make it a little bit bigger for us. So now we have to choose. Okay. If a learner is chosen at random, calculate the probability that the chosen learner plays all 3 sports. So what would be the probability that the person plays all 3? How would we work that out? Okay, so Kgola, where did you get 28 from?
Ma'am, I got 28 from the sample space there. That's it in brackets to me.
Oh, you mean with the S? Okay, all right. So now that means that
that's
over there. Sorry, that's soccer, my love. Yes.
Yes. Sorry.
Okay, that's okay. That's okay. I was just wondering where you got the 28 from. Okay, so Kanisile says 10. What do the rest of you think? Okay, so Kanisile is correct. This region over here that I am shading in blue, that's all 3. Okay, so there are 10 people that play all 3 sports. Okay, so this, another way of saying this would be hockey and rugby and soccer. Okay, so they play all 3 sports. Let's just move that down. You were quite right, Kanisile, that's correct. Whoopsie daisy, sorry, hang on 1 second. I don't have my mouse. So, Okay, so all three sports, quite right. That would be 10 out of 50 or 1 out of 5. Okay, now they say hockey or rugby or soccer. What does that mean? What does the word or mean? I can go back up again. Okay, and have a look there. So hockey or rugby or soccer. How would we work out what that is? Okay, so Kola, where did you get 19 from? You added 10 and okay, all right. So now these regions, so the question was, what is the probability that a learner chosen at random plays hockey or rugby or soccer? So it's 11.1.2b. Okay, so I think what you guys are struggling with here is that you don't know what region of the, there we go, V, where? I quite agree. That's exactly what I would have said. So you obviously understand. Chaiza, you said 5 out of 20. No, unfortunately not Chaiza. Okay, so I think V-Way, you're the only person that's managed to tell us that. All right, so that is correct. Maybe what we need to do is just talk about what the different regions of the Venn diagram mean, okay? And then we can answer questions like this, because if we don't know what the different regions represent, there's no ways that we can answer questions on them, okay? So when we are talking, let's just go back up here, and I'm going to use this one as our example. When we are talking about hockey, what is the probability that somebody plays hockey? We are talking about everything inside of the circle. That's hockey. Okay, but there are people that play hockey that play the other two sports as well. All right, so if I say how many people are there that play rugby, then I'm talking about everybody that is inside this circle over here. So the number of people that play hockey, for example, so the number of people that play hockey is going to be 5 plus 3 plus 2 plus 10, because that's everything that's inside the yellow circle. Does that make sense to everybody? So there would be 15 people that play hockey. If I said to you how many people play rugby, we would do the same thing within the pink. So we would add the 3 and 5, because that was B, and 10 and 7. Hang on a second. Why have I got the wrong answer here? Oh, sorry, this is 20. Sorry. Being stupid here, sorry, which is exactly what it's supposed to add up to. It's supposed to add up to 20. Okay, and then same thing here. If I've got 3 and 5 and 10 and 7, it's got to add up to 25. Okay, if I talk about this region over here, now let me highlight this in a different color. This green region. So now I'm including this one as well. This green region over here. What does this green region represent? If I had to ask you in words to describe the green region to me, what would you say? What does the green region represent? So in other words, A and 10 or A plus 10. Anybody know? So the green region, the area of intersection of hockey and rugby. Okay, so guys, the green region will be described as hockey and rugby, okay? Hockey and rugby. So hockey intersection rugby. So these are people that like to play hockey and rugby. Sure, some of them also play soccer, but they all play hockey and rugby. Okay, so that weird sort of elliptical, what's it, not even ellipse, it's like an eye, almost like an almond. Okay, that shape over there represents hockey and rugby. Similarly, if I now color in this region over here, and I'm going to use a different color, I'm going to use blue, and I now color in this section here. Now, I'll just get rid of that. Now, if I color this in blue, what does this section represent? Exactly. Okay, so hockey and soccer. Hockey and soccer. Okay, or hockey intersection soccer. Okay, so the intersection, there are 12 people that play hockey and soccer. All right, so that's very important that you know that. All right, this region in the middle, these are people that play all three sports. So if I now go and I color this bit in pink over here, right, that over there means, let's just get a different color, it means hockey and soccer and rugby. Okay, so hockey and soccer and rugby, so the intersection of all three. And then similarly, if I was to ask you, what does this section over here represent? Let me just go and color it in. I'll make it yellow. This one over here, this is the intersection of soccer and rugby. Okay, so this is soccer and rugby, soccer and rugby. Okay, so people that like to play both sports. Okay, so very important that we understand what these different regions means. If I talk about this bit over here, so now I'm going to highlight this bit. What does that mean? So the yellow stripes, what does that section mean? How would I describe that in words? Hockey only, absolutely. So hockey only. Okay, so they only play hockey. They don't play any of the other sports. Right, good. And similarly, there would be 9 people that play only soccer. All right, and then remember B was equal to 5. There are 5 people that play only rugby. Now, if I decide to not include this region in the center, so now let's say I'm just talking about, let me color it in again for you guys. Let's say I'm just talking about this bit over here. So now I'm leaving out the 10 that like to play all three. How would I describe this region? What would I call that? Any idea? So without the 10, so the A without the 10, how would I describe that? Any idea? Okay, but hockey and rugby includes the 10, Khola. So this region over here, that's just in green now, how we would say that is we would say hockey and rugby only. Okay, not or. Okay, so hockey and rugby only, if they're asking you to refer to that region. Okay, similarly, this bit over here that's now in blue, there are 2 people that play hockey and soccer only. And there are 7 people that play soccer and rugby only. Okay, does that make sense to everybody? How are you feeling? Am I making sense to you? Good stuff. Okay, so now that we've spoken about the intersections and we've spoken about the only, let's talk about the union. Okay, so what does it mean when we talk about the union of sets? The intersection of sets is where they overlap one another. Okay, so the intersection of hockey and soccer is 2 plus 10. Okay, that's the area of intersection. Or the area of intersection of hockey and rugby, that's A plus 10, so 3 plus 10. Okay, when we talk about the union of sets, so if I talk about hockey or rugby, what does that mean exactly? What does hockey or rugby mean? Anyone got an idea? What does hockey or rugby mean? Just going to rub some of this off because it's a little bit. Anyone got any idea what hockey or rugby means? Yeah. Isn't it interesting, Khola? These are the things that we miss along the way. Okay, so Khola and everybody else, hockey or rugby means hockey or rugby or both. And when I say both, I mean the intersection of hockey and rugby. So both means hockey and rugby. So in other words, what I'm doing is I'm adding everything inside H to everything inside R. Okay, so if I want to work out the probability that somebody plays hockey or rugby, I'm going to take the 5. So that's this 5 over here. I'm going to take the A, which was 3. I'm going to take the 5, which was the B. And I'm going to take the 2 and the 10 and the 9 plus 2 plus 10 plus 9. And I need to put that all over 50 if I want a probability. Does that make sense to everybody? That's what the intersection of sets is. So it's the one or the other or both being the intersection of the sets. Is this making sense? So in other words, it would be 34. So 34 out of 50 people play hockey or rugby or both. Okay, that means that there are, sure. Okay, so let me go down here and just create a little bit more room. Where's my thingy on? 1 second. Oh, there it is. Why is it stuck? Sorry, my mouse is not moving. Oh, come on. Oh, Neliswa, now my screen is stuck. I can't move up or down.
Or maybe try stop sharing and
I can't move my mouse.
what if you press escape in your keyboard?
Okay, let's try that. No. Okay, hang on. Guys, just give me 2 seconds. I'm sure I can get Dale to help me. Just hang on one moment.
In the meantime, how are you guys studying? Does it make sense? With union and intersections. Kumeza. Oh.
Just 1 second, guys. And now? Thank you. Thanks. Okay, I got some help. There we go. I don't know what happened.
Oh, thank you.
Computers are not my friend. Okay, there we go. At least now I can move. All right, so now what I wanted to do before this happened is I wanted to go down here. Okay, so let's just see. I can go any further down. All right, so when we're talking about the word or, okay, so if we mean hockey or rugby or soccer, they're talking about everything that's inside the H, everything that's inside the R, everything that's inside the S, including the areas of intersection. So in other words, in this case over here, if we've got, maybe it's actually better for me to just go back up and go and use this rather than try and draw others. Hang on. Okay, so let's do this. So hockey or rugby means we've got to take this 5 here, that A there, that 2 there, that 10 there, that B there, and that 7 there, because that is everything that is inside the union of these 2 sets. Okay, that's everything that's inside those 2 circles. That is hockey or rugby. Does that make more sense to you, Pumeza? Okay, so hockey or rugby means everything that is inside the circles R and B, including where they overlap. Okay, so in other words, hockey or rugby is that. Okay, what's inside the yellow? That's what it means. All right, so what you would need to do is you would need to add all of those together. So it would be the 5 plus the 3 that was the A, plus the 5 that was the B, plus the 2, plus the 10, plus the 7. That would be the number of people that like to play hockey or rugby. So hockey or rugby means hockey or rugby or the intersection of hockey and rugby. Okay, so the intersection means these areas over here. All right, so your areas of overlap. Okay, Pumeza. Exactly. So everything inside the 2 yellow circles needs to be added together. Okay. All right. So that's very important that we understand what these words mean, right? Because if they ask you to calculate these things and you don't understand what they're asking you to do, then you're not going to be able to answer the questions. Okay, so that's what the word or means. So now, Pamesa, I'm going to ask you a question. How many people play soccer or rugby? How many people play soccer or rugby? The number of people that play soccer or rugby. How many people is that? Pumeza. How many people play rugby or soccer? What are we adding together, Pumeza?
Are we adding 9 plus 7?
Okay,
Plus
9 plus, I agree with you. So 9 plus 7, yes.
Plus 10.
Uh-huh.
Plus 2.
Mm-hmm.
Plus 5.
Mm-hmm.
And plus 3 over 50.
There we go. Okay, lovely. All right, well done. So you do understand that. That's great. Okay, so everything that is inside rugby, that is also inside soccer. Okay, so that's going to be this circle over here and that circle over there. All right, quite right. Okay, good job. So if we now want to calculate the probability of this, it would end up being 34 out of 50 people. All right, well done. Good job. Okay, so I can see that that does make sense to you now. That's really, really nice. All right, so now let's go and have a look at another type of probability question. So now that we've done that, I actually want to go up to the questions at the top. Okay, and I want us to look at this table. Okay, so this is from a matric exam. They often ask us questions like this, so very important that we're able to do things like this as well. So the table below shows the results of an aptitude test taken at a company offering an apprenticeship in engineering. So it's a two-way table or contingency table. There are males and females, and they either passed or they failed the aptitude test. Okay, so in total, there were 90 people that took this test. Total of males was 50, the total of females was 40. The total number of people that passed was 70, and the total number of people that failed was 20. So they've asked us if the person who participated in the aptitude test is chosen at random, determine the probability that that person is male. What is the probability that that person is male? Okay, so Kola, you did that really, really quickly. Well done. Okay, so you got the 50 from here, which was quite right. And you got the 90 from there. That was our total. Okay, so that would be 5 out of 9, etc., etc. All right, good stuff. Now they said, is passing the test independent of gender? Substantiate your answer with the necessary calculations. All right, so now how are we going to work out whether gender has an effect on whether a person passes or fails this test? How do we do that? What do we have to use? And this is not something that's on our formula sheet. This is something that we have to learn. What do you guys think? What do we do here? Exactly, Nelly. So how do we prove that events are independent? No, Mohammed. There's a formula that we have to use, but that's not it. Okay, so you guys obviously are not 100% sure what this is. That's how you calculate probability, Mr. Pavuma. Okay, that's true for how you calculate probability, but that's not true for independent events. So there's another formula. Pumezi, you're on the right track? So for independent events, all right, so let's say A and B are independent events. So the probability of A and B has to be equal to the probability of A times the probability of B. So we can use that to prove that events are independent or that they're not independent. So if the left-hand side equals the right-hand side, then the events are independent. If the left does not equal the right, then the events are not independent. So in this case over here, we do not know because they've said to us, is passing the test independent of gender? So what we have to do is we have to work the left-hand side and the right-hand side separately from one another. So in other words, what we will do is we'll set it out like this. We'll work out what is the probability of someone, and now we've got a choice here, okay? Because we can choose. There are 4 things that we can look at. Either we can look at male and pass, or female and pass, or we can look at male and fail, or we can look at female and fail. So in this particular case, that has not been specified. All right, so you can use any one of the 4 to test this. So whilst one person might decide to go with male and pass, somebody else might decide to go with female and fail. All right, what you will find is that your answers will be the same. Okay. So now we have to make a decision. What are we going with? Are we going to say male and pass, female and pass, male and fail, or female and fail? Okay, so Mr. Bavuma, I'm going to give you that choice. What do we do? What are we doing here? What do you want to work with? Mr. Bavuma? Okay, so he's not answering. Pumeza, do you want to choose? What are we going to look at, Pumeza? Okay. All right, never mind, Mr. Bavuma. Pumeza, what do you want to choose? Male and pass, male and fail, female and pass, female and fail.
female and pass.
No problem. I like your answer. Okay, so we're going to look at female and pass. Lovely. So female and pass. So female is this column over here. Passing is this one over here. So it has to be 28 out of 90. Okay, now a good way to do this, you can leave it as a fraction if you want to, but a good way to do this is to write it as a decimal. And I'm going to explain to you just now why writing it as a decimal can be helpful in certain situations. All right, so as a decimal, this gives us, where's my pen? 0, comma, I don't know about the rest of you, but I'm getting 3, 1 recurring. All right, now what we want to do is we want to consider the right-hand side of the equation separately. So in other words, what is the probability of being female multiplied by the probability of passing? So what is the probability of someone being female? The probability of somebody being female is good, Kanisire. Coming up strong for the ladies here. Well done. 40 out of 90. Okay. And the probability of somebody passing is what, Matrix? What is the probability that someone will pass this test? Absolutely. Girl power. There we go. And another girl answers as well. Good, Kola. Well done. Would be 70 out of 90. So again, what we want to do is we want to work out what that is and write it. You can write it as a fraction or as a decimal, but as I say, if it's as a decimal, it's a little bit easier for us. So 40 over 90 times 70 over 90, what do we get? Zero, comma, I'm getting 3, 4, 5, 7. Indeed, yeah, I also got 28 out of 81. Lovely, good. All right, so if the denominators are not the same, then it makes it a little bit difficult for us to compare the fractions. Whereas if we press the SD button, then it's a little bit easier for us to be able to compare the fractions. That's why I'm just encouraging you in the situation here to press the SD button and have a look at the numbers. The other thing that you also need to have is the difference between them has to have more than 2 zeros behind the decimal comma in order for it to be considered statistically significant. Not that we ever really need to worry about that too much with high school maths. It should be sort of fairly obvious to us whether it's different or not. So now the question is 0,31 equal to 0,35 essentially? No, it's not. Quite right. Okay, no, it's not. So in other words, what we have discovered here is that the left-hand side does not equal the right-hand side. Okay, so in other words, the probability of someone being female and passing does not equal the probability of someone being female multiplied by the probability of them passing. So in other words, is passing the test independent of gender? So it is not independent of gender. So in actual fact, what we have found here is that gender does have a role to play in whether somebody passed or failed. So in other words here, what we're actually seeing, and I like this question more and more the more I look at it, is that there are more women that pass than men. So sorry, guys. But yeah, here the ladies come out tops, unfortunately for you. Okay, so not independent of gender. So in other words, gender does play a role in whether the person passed or failed. Okay, does that make sense to everybody? Sorry, I know. I'm sorry, Mr. Bufuma. That question must have been set by a lady. Okay, so it's just a little bit of useless data for us to have. Oh, guys. You guys are very funny. Okay, so let's see in the last couple of minutes that we've got left, if we can maybe try and do some fundamental counting principle, because we've had a look at Venn diagrams, we've had a look at contingency tables. So let's see if we can have a look at fundamental counting principle and see where we end up. All right, we might not get to everything, but let's just see what happens. Okay, so in 11.2, they've given us a 4-digit code, okay, and it's not allowed to begin with a 0, are constructed from the following set of digits. So 0, 1, 3, 4, 6, and 7, okay, but it cannot begin with a 0. First question that they ask us in 11.1 is how many 4-digit codes can be constructed if the repetition of digits is allowed? So in how many ways can this happen? What should I do here? All right, I have got 4 blocks essentially that I'm filling. So the total number of ways will be the ways in which each block can be filled. So I'm not allowed to start with a 0. So in how many ways can I fill the first block? Have you guys done this at school, or am I sort of asking you questions about things that you haven't done yet? Would it be better if I rather explained this rather than expected you to tell me the answer? Haven't done it. Okay, all right. Yes, Mohammed, I remember you telling me you haven't done it. Okay, all right. So let me explain this to you. Oh, let's rather do it that way. Okay. So in other words, when we want to make, so this first block over here, okay, so this one where I've got a dot above it, that is the first number in the 4-digit code. It's not allowed to be a 0. So that means I've got 1, 2, 3, 4, 5, 6 other numbers that it can be. So in other words, there are 6 ways in which I can fill that first digit. The second digit, all right, can be a 0 now, all right? In fact, it can be any one of these numbers because I'm allowed to repeat my digits. So now, including the 0, how many numbers have I got? I've got 7 numbers. Okay, so when I count how many, 0, 1, 3, 4, 6, 7, and 8, that gives me 7 numbers to choose from. Because I am allowed to repeat my digits, it means that there are 7 digits I can choose from the third number in the code, and it also means that there are 7 numbers that I could choose from the last number in the code. Does that make sense to everybody? Is it making sense, guys? Mohammed, is that okay? All right. So in other words, there are 2,058 different codes that I could make using, or 4-digit codes that I could make using those numbers if repetition of the digits is not allowed. Okay, now the next one is going to be a little bit more difficult to answer because some people haven't done this section. But anyway, let's just do the best that we can. All right, and I think what we'll do is we'll leave it there, and then you guys have got time to go and do the quiz. So now, how many 4-digit codes can be constructed if the repetition of digits is not allowed? All right, so remember, in the first block here, we're only allowed 6. Okay, because we're not allowed to have a 0. Right? How many numbers do we have to choose from in our first block? So in other words, whoopsie. Okay, so Chaiza, you're saying 6 by 6 by 5 by 4. Okay, can you see there? I know this is probably going to be a little bit difficult. I mean, I've now started it right at the very end when it actually does not help you to start something that's new. Basically, can you see there? What we're doing is this, all right? We are not allowed to repeat our digits. So if we've used one of the digits, we cannot use that same digit again, which means that we've got one less digit that we can choose from. So when we fill the first block, remember we're not allowed to use the 0. So that gives us 6 other digits that we are allowed to use. Okay. But when we fill this block over here, we are not allowed to use, so if we've already used a 1 or a 3 or a 4 or a 6 or a 7 or an 8, we are not allowed to use that again. Okay. But we're allowed to use the 0. So that means there are 7 digits. So we've got one less digit that we can choose from. So here there would be 6 digits we can choose from. Because repetition is not allowed, that means there would be 5 digits there that we could choose from by 4 digits over here that we would be able to choose from.